Greetings, ladies and gentlemen. Today we're talking about graphs of sine and cosine functions, specifically their amplitude and their period, because they are in fact periodic functions. And for problem 25 on page 373, we are asked to not only find the amplitude and the period, but also graph the function. So in order to find the amplitude, that is going to equal to the absolute value of A. In this case, A is the negative 2/5, so the amplitude is 2/5.
It just switches to negative?
Yeah, it just makes it positive.
Because when I put it into the calculator, it gave me a decimal. Because I have...
Well, yeah, it's still, 2/5 is the same as 0.4. Yeah, exactly. So let's see, the period, the formula for that is 2 pi over k, where k is the coefficient of our theta. So that would be 2 pi over 9, and that doesn't simplify. So 2 pi over 9 is our period. So let's graph this.
Okay, so that's why I was so confused, because it wasn't going in.
Yeah, so leave it as a fraction. I mean, as a decimal, that would just be disgusting. So let's see, as the highest we go is 2/5 and negative 2/5. Right, and it finishes its full cycle in 2 pi over 9 radians.
So what did you just do?
So what is half of that? Well, that would be pi over 9.
You do so much differently than the book does.
Okay. Right, half of that would be pi over 9, or 2 pi over 18.
The book just goes up like this pi, then it goes 2 pi, 3 pi, 4 pi, 5 pi.
Right, yeah, I would have that as well, depending on the problem. And then half of pi over 9 is pi over 18, right? And then what is 3 of those? Pi over 18, 2 pi over 18, 3 pi over 18 is 3 pi over 18, which actually reduces, doesn't it? Pi over 6, I think.
What?
3 pi over 18, 3 goes into 18 6 times.
I guess.
Right, but that's how I'd set it up. And now this is a graph of the sine function. However, this is an upside down sine function. So sine starts where? At 0, and this is upside down, so instead of going up to 2/5, we'll go down to 2/5, and then 0, and then 2/5, and that. And then we'll draw a nice little curve, nervy. Close enough. Right, something like that. So that's what our graph would end up looking like. Look-a-like-a. So, there's that one. So that one's a little bit of a tricky one. So really, I actually do almost no work finding additional points. I just find my main 5, kind of, for the sine or cosine functions. Technically, I could find more accurate values here if we wanted, by plugging in some different values, like if I wanted to plug in, like, I don't know, pi over 36 or something like that. However, I'm not too worried about that. So I just do it like so, and we rough it. So other questions? Is there any from this batch, or should I jump on
39.
to that? 39? Okay, so we will jump on to... All right, so here they gave us the amplitude and the period. Awesome, this is a good one. There, snap.
I think that was...
Yeah, I think that's a broken pencil sharpener. My apologies.
Yeah.
You can check next door real quick if you want.
You gave up so much homework last night. I spent an hour doing it.
I'm sorry.
Saying again, I kept getting distracted.
So let's see. The amplitude is 0.34. That means A is going to equal plus or minus, right? 0.34.
Sin.
Right, I'll get there. Let's see, all of these, earlier in the directions it says, write an equation of the sine function with each amplitude and period. Let's see, the period is 0.75, so that means, 0.75 pi, and that is equal to, what, 2 pi over k?
Oh.
So what I'll do is I'll solve that equation for k, is what I'll end up doing. Technically, I also, my amp equals abs of A. To solve for A, you would have broken that into two separate cases where A is equal to the positive amplitude and A is equal to the negative amplitude. If you wanted to do super appropriate, like absolute value equation
So I got a
solving.
question. If A is positive, would that like
Be
the
a-
equation in the beginnings? So like in previous, so it'd be
Yep.
like y equals 0.34. Would that make the absolute value negative, or would that make it still positive?
It'd still be positive.
Still positive, so
Yeah.
the absolute value just sort of stays.
Yep.
All right.
Let's see. So I multiply both sides by K, and now I'll divide by 0.75 pi.
Wait, so you multiply K.
Because I'm trying to solve for K from this. So I'll end up with K equals, the pi's cancel out. I get 2 over 0.75, which is the same as 2 over 3/4, right?
Wait, what did you get?
So that's the same as 2 times 4/3, which is 8/3. So that's where that 8/3 came from.
Wait,
if we wanted
how'd you
a
get 3/4?
non-decimal version of
Did
it.
you get 3/4 again?
0.75 is the same as 3/4. I was trying to go for a non-decimal version, which it looks like the book did as well. And since this is a sine function, this is going to equal y equals a times sine of k theta. K theta. And I will have y equals plus or minus 0.34 sine of 8/3 theta. Right? And that would be my answer. So it's a matter of plugging in what we got, solving for what we don't.
Scroll yet.
Did we do problem 41?
Yeah.
I want to do 41.
Wait,
or maybe I'll do a cosine version of that. Did we do
wait.
47? Yeah, we did.
Yeah, I got that 47. Wait, don't scroll yet. I'm not done writing this down.
Yeah. Stop it. I'm going to keep going just for the sake of the video. No. 47 is a good one.
I thought you said you were going to do 41.
Yeah, 47 is at least a cosine function just to
No,
get a
see,
mix.
41 was because I did 30 divided by 2 and that equals 15.
But cosine, this problem's got the same exact situations, just cosine. Darn it. Here we go, 47. Come on,
I did
don't
the exact
freeze.
same thing, I just divided by 2.
So let's see. A would be plus or minus 17.9.
Yep, agreed.
Right? The period was 16, and that would equal 2 pi over k, right?
Yeah, all I did was divide.
So to solve for k, I'd multiply both sides by k.
Why wouldn't you just divide by 2?
You could do a couple other things first if you wanted. So k times 16 equals 2 pi. And then to get k by itself, I'd divide by 16.
Yeah, you could just divide by 2.
Not quite.
Yes.
That wouldn't.
Okay.
You'd need to do more than just that. And then I'd end up with pi over 8.
And then you just switch it. Whatever.
Yeah. You could reciprocate. You could do different things. Yeah.
So, should I divide by 2 every time and just
No, I recommend solving algebraically. I'm not going to give you a set rule.
I can't just brute force it?
No. Just solve algebraically. Don't memorize some weird arbitrary way to do it. Just know the formula and then rely on your algebra skills each time would be the preference. And this is a cosine function, so that's why this would be y equals plus or minus 17.9 times the cosine of pi over 8 times theta. And I don't think I said it necessarily in the video, but anytime your k has a pi in the numerator, your period will actually end up being an integer, a non-pi thing, okay? And sometimes if, say, I wanted to map the lunar cycle or a tidal chart or temperatures, the period of those things would not necessarily be related to pi, right? So like the lunar chart, I think, goes through its cycle in 28 days or something like that. So I would want a period of 28. Actually, yeah, let's ask that. Little side question, bonus example on this
So do
video.
we get an extra point?
Nope. What is k if p equals 28?
Wait, what's P?
Period.
Oh.
Period.
Just write PER then.
Yeah, sure. So the way I would do that is I'd say 28 is equal to 2 pi over k. And then I'd do my old multiply by k trick. Or you could just reciprocate. There's a bunch of ways you could do this. K times 28 equals 2 pi. And then divide. And you guys probably see what the answer is already, but that's okay. So I'd get k is equal to pi over 14. So I just think that's interesting that you can have a numerical result for your period. And actually, just to show that, that's actually, this is a little bit of calculus right there. Ignore that. You've seen nothing. Don't save. New. Let's say I wanted to graph, nope, Command G. Comanche? Command G. Comanche? Apache. Hello. So if I want to do cosine of, say, pi over 14 times x, or my theta, right? I'm going to hit OK. And actually, let's see. Would you like to switch your preferred angle units from degrees to radians? Yes. But I think I want to change the graph to a non-trigonometric axis. And notice, in this case,
I'm confused.
We'll see. And there we go. All right, and I'll regraph it. So notice the period actually ends up being 28, which is a completely regular integer, not some weird like 17 pi or something like that.
Well, why
right?
would it be 28?
Because the value of k was pi over 14, and that's the only way this could work out for the period to be some not weird irrational number.
I thought period was between the distance between.
Right. So
that
from summit
and
to
that.
summit, it's over at 28 is where it completes one full cycle.
Oh, so.
Right. So and if I could do pi over 30, and that would be, that must be a period of 45, maybe? No, 60, I think. Yeah, 60. Interesting. So it seems as though if I did pi over 5, the period is now 10. Okay, so interesting.
I don't see a pattern. What's the pattern?
Right, so if it's pi over some number, the period is double that denominator.
So if it was 10, it would be 20? I was thinking like 10 times 10.
Yep, and 20. So yeah, so that's helpful for most real-life modeling situations where the periodic cycle would not necessarily be related to pi in any way. So it turns out your k value will have to have a pi
Will it be on the quiz?
in order for that to work. Yeah, we'll have some problems like that at some
Good,
point.
because that's easy.
I see, you like a challenge.
No,
All right. Well, internet
I don't
friends,
like a challenge.
we love challenges. So, okay, internet friends, we'll all talk to y'all later. Doo-doo-doo-doo.